Everyone, this is Mr. Ganta and I'm here with the Kaprekar's constant Python program. If you don't know what Kaprekar's constant is, you can check the video in my description about how it is done and how it is and what number it is. Let me brief you that one. Give me a small briefing of how it works. If you give a 4-digit number with two different values, like some number like 1, 2, 3, 4, or 4, 3, 2, 1 something, or 5, 6, 7, 8, and it must not be any order of something. It can be anything like 7, 7, 8, 9, like 3, 9, 8, 7, something like that, anything. And we arrange it in descending order and also in ascending order, and we do the math like descending order minus ascending order, and we do that, and after that we get a remainder, and we rearrange that answer into descending and ascending, and we do the math like that, and we will repeat that as long as we get the answer like 6174. You see that here. I mean, we did the program here. If you want a detailed explanation about how the Kaprekar constant works, you can check out the video in my description. I just did the theory part of it, not a program. So if you're fun with math, you can go watch that. And if you are also interested in coding, you can watch this video. Here we are passing a function with an argument n, and we are giving it as a string. We are formatting this as a string so we can arrange it as much as we can. And we have passing the largest variable. We gave the largest variable int dot join sorted. These are built-in function in Python. Num string is this one, and if we have to reverse the number, it can also be true. Like if we gave a number like 9876, like 6798, we should reverse that to 9876, so it will be a descending order. So like that, and smallest will be like the smallest sorting, like it sorts the number into ascending order. This one sorts the number into descending order. This one sorts the number into ascending order. So we can return the number like descending minus ascending, return the value. Next we gave another function for the steps. This is the calculation part and this is the steps part. I mean, we should have to keep track of the steps so we can find out how many steps we reached for that. And next let's see about Kaprekar's constant function. While we gave the steps as initially as 0, and after that we gave our loop. I mean, first we should start with the step 0, right? And after that we gave our loop, like while n is not equal to 6174, while 6174 is the Kaprekar's constant, the steps keep incrementing. Like you have the Kaprekar step, n is equal to Kaprekar step of n, step keep incrementing. Like if we gave a number and it did the first step, it will be counted as step 1, and after that it does another step, it will be counted as step number 2. You will get a much idea of that while I run the program. Okay, don't get confused with the code. And after that we are printing the steps, like we are formatting the steps like this is a string and this is the variable here, and this is the number of steps that is happening here. And if the n reached to the value, this is not the number of steps, this is the number, this is the value. And if the value has reached 0, and it prints this thing like it has reached 0, the number is not valid for Kaprekar's process and it breaks. And if the number has reached 6174, it prints the value by formatting it into steps like Kaprekar's constant has reached 6174 in number of steps. Number of steps can be anything, 1, 2, 3, 4, 5, 6, or maybe 7 or more. And here comes and it returns this step function, this function. And here comes the main program. We are entering a 4-digit number. Here we are taking the input, and if it is a 4-digit number, it must be in between 1000 and 4 nines, and the length must be greater than 1. And we are doing the Kaprekar constant function with the number we have just entered. And if the number is not in between 1000 and 4 nines, and also if the number hasn't did not have any two different digits, I mean if the number have only one digit, it will print this. If the number must have greater than one digit, or greater than one volume. And if we give 4 4s, the code will show this one. I mean this is like a inbuilt exception. I mean user defined exception. We are doing this here. If it is in between that, we can do Kaprekar's constant. The rules of Kaprekar's constant are the let me see that for you. The starting number must be a 4-digit number. That's first rule. The second rule was the number must be at least two different digits, and the process is repeated until 6174, and like that. Here the second rule is the number must have more than one digit. I mean it must have two different values. So let me run that program for you and see and show you. Python 3 kc.py. This is how you run a program in terminal, or you can just press this button in VS Code. I prefer to run it this way. This is how I saved my program, kc.py. Let's see, and it is asking me to enter a 4-digit number. Let me give it 3924, and it reached in 3 steps. Pretty quick, right? I gave a nearer number. Let me tell you another example of the same digit, a number which has same digit, like 4444, and it's saying, what does it say? Let me zoom that for you so you can see it very clear. Please enter a valid 4-digit number with at least 2 different digits. Did you get that? Okay, let me do another one, only with 2 different digits, like 5656. See, it asked we should give at least 2 different digits. We gave that, and we got the answer in 4 steps. So let me tell you another time so you can get this very quicker and easier. We are giving a number, and it's taking it in strings, and the largest must be the one which is sorted in descending order, and the smallest must be the one which is sorted in ascending order. And this is the function that returns the largest minus smallest, which means descending minus ascending. And this is another function which calculates the steps and prints the number of steps, and prints the number of steps too, like prints the process of the steps. And we have giving the steps as 0 initially, and while we are giving a loop for the 6174, while the n is not equal to 6174, it does the Kaprekar step function, and the steps keep implementing as we proceed with the steps. And we print the steps like this is, let me show you the output in this. This is step number 1. Steps means this one. This keeps incrementing, and the number will be printed here. See, like that. And if the number have reached 0, the number is not valid for Kaprekar's process, because we have to reach 6174, not 0, and it breaks. And if the number has reached 6174, it prints like Kaprekar constant 6174 reached in number of steps, like see this one, Kaprekar constant reached in, see that clearly? Did you get that? Reached in 3 steps, like that. And it returns n. N is nothing but this function. And here comes the main program. We are taking the input, and the input must be in between 1000 and 4 nines, and the length of the string of the number must be, which means it must have greater than 1 digit, 2 different values, like 2 or 3 or 4, must be anything. 4 different values, 3 different values, 2 different values, but it should not have only one value like this one. You see me do this 4 4s. And next we are doing the Kaprekar constant def function with this number we have entered. And else, if the number has only 1 digit with four values, and it will print this one. Please enter a valued 4-digit number with at least 2 different digits. It has done this here. Let me expand that. Please enter a 4-digit number with at least 2 different digits. This is the program. So share this with your friends who loves coding and math. Coding and some say coding and math are 2 different things. Coding and math are more similar than you think. And share this with your friends who loves math too, because this is fun, right? when you are doing something fun, you must share it with your friends, right? So thank you for watching. Please like, share, and do subscribe to my channel. Thank you for watching.